Training a deep learning models from scratch can be expensive. It takes, let's say, tons of data, huge compute resources, and also a lot of time. But what if your model could stand on the shoulder of other models? So that's where the transfer learning comes in. So here's how it's work step by step. So in the beginning, select the pre-trained model. For instance, ResNet, it's already trained on ImageNet, let's say. And start with the model that has already been trained on a large dataset like ImageNet, Coco dataset. This model already knows how to detect general features like edges, textures, and also shapes. And for instance, if you have an industrial dataset, and if you try to use ImageNet, the features might be not be, let's say, well detected. So in this case, I will show you next time how to do stuff. And the next step is to freeze layers. For instance, this is our model, and this is, for instance, these are the layers. I will try to freeze these layers here, freeze the weights. So these weights will be constant. It will not be updated. Let's see, it will be, for instance, uh, forward forward propagation, and the back propagation, it will only update this, for instance, layers here, and this won't be updated. And by freezing the earlier layers, you preserve the features that the model has already learned. And the third step is replace the output layer. So if the network, let's see, or the pre-trained model is used for classification of 1000, let's say, classes, and your dataset has only two class or three classes, you have to update the head, I mean the output. So now it's time to adapt the model to your specific problem. So replace the final output layer with one that match your, let's say, your data set. And as you said, for instance, classification. And oops, the fourth step is fine tune, which is adjust the weight using your new data set. So this step is just refine the model, allowing to specialize for your task, while still, let's say, benefiting from the knowledge it started with. And for instance, when I try to train, just an example, YOLO, I will not train it from scratch. I will try to freeze some layers, let's see the earlier layers, and see how it's performing. If it's performing well, I will try to continue. Otherwise, I will try to, if I have a good data, I will train it from scratch. And what are the benefits of the transfer learning? It's reducing time training, less data required, and also improve the performance. And it's also using the existing knowledge. So this is the goal behind transfer learning. It could be asked about what is the transfer learning, why we need to use it, what is the advantage, and etc. That's it for today. And if you have any question, just drop it out in the comment below. Thanks for watching. Bye bye.